All right, so this talk is about solving the problem of increasing the responsiveness in UIs, specifically for use cases that really need to provide a low latency user experience. So just to give an example of what I'm talking about, we've all seen these things where you have to, sign with the stylus, and they usually suck. You end up signing your name, and it doesn't look like your signature that you make when you're using a pen. So, why is that? There's several issues. There can be issues with the device, like accuracy, sensitivity, the sampling rate. Those are all mostly hardware issues. And then there's latency. Latency is usually the software's fault. When you have high latency, it kind of messes with your hand-eye coordination, and it prevents you from representing what you're trying to draw. It really becomes tricky because you have trouble making the difference between an offset in the pointer while you're drawing and a lag, so you end up scribbling. So it's really important to solve this in order to get that experience right for web interfaces that would be driven by a stylus, like a Paint application, for example. So where does this latency come from? There are several parts. Now this diagram is a little bit hand-wavy because I'm not an expert when it comes to the compositing part of the pipeline. But basically, at the front end, you have the input latency, and that's everything that goes up to your web application's code. So this purple square here is your application's code, and the web app probably has an event listener that looks for pointer events, and then it just does a change to the DOM or draws something to a canvas or something like that in response. And that often takes only a couple milliseconds. So if the app can do its work in a couple milliseconds, how come the latency is more like 50 or 60 milliseconds in real-world applications? It's because there's a lot more going on in the browser. So the input latency is just the process from getting from the physical input all the way to the time the event listener gets triggered. And after that, once your application order changes to the DOM, to get those onto the screen, well, the graphics pipeline is in stages, and they're separated by vSyncs. And what we have here is a pretty deep pipeline with multiple stages. So at each frame interval, everything moves forward, like between the red rectangles, everything moves forward by a step at each vSync. So that introduces a delay. Now this deep pipeline, it's there for a reason. It helps us get smooth results, and it gets us also higher throughput, because the pipeline allows us to do certain things in parallel. And that's often what you want, but for the example of a stylus-driven UI, that's probably not what you want. You probably want to sacrifice some of that smoothness to get latency in return. So the traditional solution to this is to use single buffering. And in single buffering, well, the application simply writes pixel values into a buffer that gets scanned out directly. So in the simplest incarnation of single buffering, you can't have any compositing, so that's okay for a full screen app. But when you have windowed applications or just a region of a web page that needs to update, well, then you need something called hardware overlay. So this is a feature that not all graphic systems have. But when you have this, what happens is you can defer simple compositing operations to the hardware, and these compositing operations happen during the scan-out pass, and that allows things to go fast because you don't require a compositing stage in the software. So this allows us to skip the UI compositor stage and the OS compositor stage if there is one, because that's not always the case. And that's how you can get near zero latency. Now for the canvas element, here's an idea that we're in the process of implementing, something we want to explore. is to kind of do a pseudo single buffering, where the compositing pipeline remains as it is. We're not changing it, but the canvas, instead of taking a snapshot of its contents and then passing that to the compositor, it's going to just pass a reference to its active render buffer, and frame after frame, it keeps passing a reference to the same render buffer. So what that, the result of that is that at this stage here, where we're doing the where the UI compositor is doing its work, it's always picking up so it's compositing frame. Oops, sorry. Let's go back. It's compositing frame n-2 while frame n is getting drawn, because both the purple box, it's painting into the same buffer than the buffer that's being referenced by the layer that's at the later compositing stage. So this allows your content to just skip forward in the pipeline. So that reduces latency by 1 or 2 frames. So the reason that it's 1 or 2 is because we're no longer vsync aligned, so there's an actual erase here. There's a race condition, and it can cause tearing if you end up doing this scan out during the modification. Well, actually, in this case, we're not doing a direct scan out, but it's in the next slide where we're actually using a hardware overlay. In this case, while you're painting frame n, the scan out that's 3 or 4 frames further down the pipeline, it's picking up directly what you're drawing. And in this case, this is where you're exposing yourself to tearing. And the UI compositor at this stage, it's not actually doing any presentation work for the canvas. Its only responsibility is making sure that the hardware overlay layer is positioned at the right place on screen, corresponding to the document layout. So there are some issues with this approach. What is that? Canvas updates, well, they're no longer synchronized with the DOM, so we're actually breaking the spec by doing this. And because of this, because we're removing this guarantee, well, the low latency mode needs to be opt-in, because there are apps that kind of expect these things to be synchronized. Also, if you're painting during scan-out, I already mentioned this, you get tearing artifacts, but also, if you're doing a type of animation that needs to clear and then redraw the animation, it always restarts from scratch. Well, then you can actually get flickering, because the scan out might sample the frame right after you've cleared and you haven't drawn anything, and that's bad. So there are ways around this. To avoid flickering, what you want to do is go back to doing double buffering. But your double buffering, you do it in JavaScript instead of letting the compositor do it. So basically, you have 2 canvases, one that's not on screen and one that's displaying. And you draw on the one that's not on screen, and when the frame is ready, you copy it. But because this copy is not coordinated with the compositor, you still maintain the low latency advantage.
Does this force the canvas into the non-display list mode?
Yes.
Yeah. Okay.
Yeah. So this assumes we're not using the display. Everything is immediate. We're not deferring any of the rasterization. And
so, how do you do the blitting in JavaScript? So you just like copy the pixels.
You do a draw image from one canvas to the other.
Canvas to the other. Okay.
Yeah, that's how the blit works. Yeah. So then the next step is we want to avoid jank. So what I've described so far, the rendering is all handled on the main thread, and the main thread is sort of a busy place. So there's the off-screen canvas interface that would allow you to do this on a worker. So this hasn't shipped yet, but the implementation is pretty far along. It's getting pretty close, and this would allow you to run your highly responsive UI in isolation, so you can get away from the jank on the main thread. But there's still one important thing that's missing, is that we don't have input events on workers. So right now, the only way to get an input event to relate to a worker is to trap it on the main thread and then post message it. But if you're tracking it on the main thread, well, then you just put the main thread back into the loop. So you'll get input jank. And that's not good. And that's where Mustaq's work comes into play.
Everyone. So essentially what Justin mentioned, right? Like, so since there is no input event for workers today, right? This is what we can do now. So suppose we want to have some kind of a stylus drawing app where the drawing part is done on the worker thread, right? So we have to add, say, pointer removal, mouse move event listener in the main thread, and post message relevant data to the worker thread, and the worker thread will do whatever it does, then post message back, and maybe the main thread updates the DOM based on the result like that. And this is something we don't want because main thread is the bottleneck here, right? If main thread is slow, we are slow, right? Like essentially, whichever thread is slow, that is the bottleneck here. And instead, we want something like this. I quickly. Okay, so we are something like that. Instead of adding just message listener in the worker thread, we just want to add pointer move, pointer down, listener in the worker thread. These are worker JS, right? And it will draw the points that we need. And I'll just quickly show the demo here. So the demo is based on polyfill, so it is not giving you any performance benefit, but just the proof of concept essentially. So here we have two canvas, two offscreen canvas, right? And we have a single worker and two instances of workers driving each of them, right? So and the first worker is drawing whatever I'm drawing on this canvas, right? Listening to the pattern events in set rectangle and drawing accordingly. Second canvas is listening to the same events on that top rectangle, but drawing a mirror image of this, right? So, that's what we want here. Like, so one quick note about this point. So this add event listener in the worker thread, right? This comes because a scope or a dedicated worker global scope is a event target. So we can add event listener, right? But since currently we don't support event event, adding an event listener for say mouse down doesn't really work. There's no plumbing there. But this message is a special kind of event post message. This works. So there are a few challenges here. So I'll slightly expand the scope. So instead of saying that we want to handle events for say Offscreen canvas only, we'll expand the scope for any kind of event handling quickly, right? So what are the challenges here? So we have two scripts, one in main thread and one in JavaScript. One is the worker thread, and one requirement is of course we want thread isolation, right? Two threads can go in their own course. Like anyone can be fast, anyone one of them can be slow, right? Another requirement we have is that the DOM is owned by the main thread, right? Main thread can see the DOM, can modify the DOM the way it likes, but this like any part of the DOM is not visible from worker by design. We don't want worker to see them, right? And that kind of adds conflicts to the last requirement we have, right? Say we want to handle some kind of a pointer move event in the worker thread, like dragging the pane, and that will do something with this DOM, right? So since we want, we want to do something with the DOM, say for example, we want to drag something from this div to this div, right? This result will be updated in the DOM ultimately, right? So that means the event to DOM relationship is still there, right? So I'm talking about the general event, not just canvas, right? So think about dragging. Let's say I want to drag something from here to there, right? So event to DOM relationship is there, right? You want to reflect, you want to show the outcome of your work in the page. User should see something.
Do you need that requirement for solving the low latency pen on a canvas?
No, yes. For canvas, we don't know it. Don't need it. That's what I'm saying. For general, this is the bigger scope for general event handling. not just canvas.
Yeah.
Right. So these are the kind of conflicted equipment that makes the general event handling harder, but yeah. So these are canvas. Like the good news for canvas is that the strong tie is not there anymore, right? So drawings inside the canvas doesn't really modify the DOM tree, right? So that means like only thing that we need about the events is really event to canvas coordinate conversion, right? So if you're drawing on the page, which part, like what is the coordinate that matters to the canvas, right? And for that we only need that kind of composite information, right? Exactly where in the screen the canvas is, and for that we have composition thread already, right? So that means workers can directly talk to the composition thread to get the information and update the coordinates accordingly, and that really works easily for canvas. So that and this kind of like exactly what is called composite scrolling. So here's a proposed solution that each worker that wants to listen to an event will get a dedicated compositor layer somehow, right? And then compositor thread will do the hit test and event forwarding to the appropriate worker, right? This is simple one. So we need to address a few issues around that, like for example, how to bind event targets to workers, right? Like this is easier question to solve, but there are questions like what happens to the main thread dispatch. I'll go through that. And the third point is that how to expose the JavaScript event classes to the workers. So the first one, how to bind event targets to the worker, is really an API issue. Like we can have something like when we construct a worker, we can say person an option that these divs are for this worker. This is the easiest thing to do because worker constructor already allows passing options.
We're switching back to the general case, not the canvas specific case.
Yes. So because like if we solve the problem only for canvas, then we need a completely different design for general case, which is not good, right? But yeah, this is canvas. I come to that, right? So what we can do is file constructing, but then if some app needs to modify the target on the fly, that creates an extra overhead, right? So this is not good. So a better solution seems to be like some kind of a binder API, like the one we did in the polyfill demo. Like worker will have a bind event targets call, which says okay, bind or unbind these targets from the worker. And another solution is that without any API change, you can just transfer control to the when you transfer control of the Offscreen canvas to the worker, that kind of allows you to add event listener in the worker thread to the Offscreen canvas. So what happens here is that in the main thread, the Offscreen canvas is created, and then this object is posted to the worker thread. Worker thread gets that object, and then add event listener directly to that Offscreen canvas object that it gets. Okay, this is better for Offscreen canvas because if you think of the worker thread scope, like it's we don't have to add all event listeners to the global scope. Instead, we are adding it to the Offscreen canvas object. It's not that your single object holds all event handlers. But yeah, the problem is that this doesn't work for general case, right? And it doesn't even suggest any solution. For example, if we want to do something like that, like for example, we added a say we add a mouse event. We have a div, we want to transfer it to the worker thread, right? Then that means all the DOM objects has to be exposed to the worker thread, which is kind of hidden, right? The whole DOM tree. So this is something we don't like. So I think solution B is better, although our primary application is canvas.
I think you want to go with C, probably initially. Just like if we want to do B, we need to solve a whole class of other problems, which is like a 5-year effort type of thing.
I feel like the rest of the presentation might outline their proposed solutions to those 5 years.
Yeah, not really. Like this is very other side of the world. So yeah, so we don't have any 5-year plan yet. Okay. Yeah. Okay. So and what second question is what happens to the main thread dispatch? Like so, say so we have mouse move event. the composition thread forwards to the worker, right? Forwards to the worker. How the main thread sees the event. The event can vanish. Does the event vanish from the main thread, or become uncancelable in the main thread, or just goes as is in the main thread, right? So if that event vanishes from main thread, that kind of makes it easy for developers to reason about the independent nature of the worker, right? You're handling the events in the worker, not in the main thread. But that has all sorts of problems. For example, if you forward only the mouse down event, then the mouse up event goes to the main thread, mouse goes to the worker thread, the pairing is gone, right? That mouse and mouse are pairing, and then that means focus change and everything will be challenging, right? So another possibility is following the touch event model, right? So the event that forwarded to the worker thread will become uncancelable in the main thread. So the main thread will know that the event is handled somewhere through this uncancelable bit, right? That's all the pairing problem. Like if you listen for mouse down, mouse up, you'll still see this event pair in the main thread. But the problem with the default handlers is there, right? For example, if you have a worker thread handling a canvas and there is text rows in the main thread, and the application wants that if you click on the worker thread, the focus won't go away from the main thread text box. So it will want to prevent before the event in the main thread, right? But it's uncancelable. You can switch the focus away, right? And C is like just fire the event as is in the main thread and the worker thread. This is harder for developers to reason about because the possibly double handling, but possibly it's okay because app knows about it, right? Apps knows that there is a worker for this type of event, so it has to deal with it anyway. And alternate solution is also possible. So they've started a discussion in the point event GitHub. Has a point event GitHub issue about defining a new type of low latency input. So which is kind of like instead of saying that pointer move, pointer down, the traditional events go to the worker, right? What if we have a completely new type of event, because we have to solve the low latency part in the input side anyways. We have currently physing align input, right? Which is kind of buffers the input until the signal comes. We have to do it anyway, right? So, and there are a few possible ideas there. For example, allowing switching to an unbuffered mode for certain events, which Rick proposed is kind of this what Android has, right? For example, on pointer down, if you have a pointer capture, you say that okay, from this pointer down until the release of pointer capture will forward the event, the event with low latency. There is not phasing aligned. Or another possibility is instead of events at all, can we have a polling API, like the gamepad API we have, right? The worker thread will really poll the device to get the status, like which button is pressed in the gamepad also, right? This looks reasonable, but one problem it has is that if you miss a click in between polls, it's gone. It's not buffered or anything, right? Or also someone has proposed an input observer API, which I don't know much about, but these are the other ways to handle this solution. And the other question we need to resolve is how to expose the JS event, like UI event class, to the worker, right? So there are some elementary data types. I don't know whether they're exposed to worker or like downstream. Some of them are, but I don't know for the big set of events, right? But the bigger challenge is like events have some attribute that refers to DOM, right? So this window attribute, right? So window is not exposed to worker at all. Like how do we expose UI event to the worker thread without exposing this field?
I mean, you just add exposed equals window on that attribute and exposed equals window common worker on the top on the UI event.
But this only this field.
Yeah.
Okay.
But I mean, it will require you to go through every single event class on the platform and evaluate every field.
Yeah, I went through some of the focus event, pivot event, looks like this is the only big one. Like other than this elementary, I think elementary ones are easy. They are not written down.
I mean, for starters, you just remove any DOM references, target, whatever.
Yeah.
No, the object
Target is an event target.
has a field like that, right?
Yeah, I mean, target's an event target, but originally it was an element, so.
Yeah.
Yeah.
Well,
But it is an event target, so it'll be the canvas object.
Yeah,
Okay,
if you do the
Sure.
canvas one, it'll just be those.
Yeah, that's fair, because you had something to add the event listener.
Yeah.
Yeah. It's just all the things in events, but don't really work with canvas, like you don't have bubbling.
I mean, that's also true for like a bunch of, like, you don't have bubbling on index DB.
Yeah, bubbling, like
Yeah.
in the worker context, bubbling doesn't make sense because it's kind of a single object DOM, right? Something like that. So whether you allow bubbling or not doesn't really matter, right?
Well, it does matter when if you have the concept of nested things. So if you were sending some proxy of elements to the worker and one was contained in the other, whether you support bubbling is
okay, yeah.
something you need to
So
consider.
is there a concept like sending a proxy of the DOM like that?
Well, no, I mean,
That's what you're gonna show us.
Yeah.
That's why you want to do C and not B.
This is the idea thing.
Yeah,
Do see.
Yeah, like that's it. It's really for me. It's really the very early stage of the work. So these are the questions you need to answer. Like and I added a link to the docs we have. Feel free to comment. Yeah.
Right, so here we're not, unlike a lot of the presentations you've seen so far, we're not showing things that we've done, we're showing things we're thinking of doing. So we're really here just to get feedback.
like I think on the worker you should just have add event listener only support passive. And
Interesting.
I think, yeah, like passive or, you're not allowed to, you set true, you get an exception or something. Like,
right. Yeah,
or
exactly.
you have to pass event listener options or things like that. I don't know. Because the whole prevent default behavior is
Yeah.
Or just like canceling them does nothing. Like,
well,
Are you saying because you want to send them to main as well?
Yes.
I was
You
thinking
might-
it would be a lot simpler to just only allow, if you capture them on the worker, they'll send them to main.
So in a lot of use cases, you might have things on top of it. I guess the worker wouldn't know about
Well, that's going to be up to the compositor, right? If the compositor hit tests to something on top, then it's not the.
Yeah, when you say don't send to main at all, then the pairing is gone, right? Like
what about the
That's,
element, right?
so you added a mouse down listener but not mouse up, right? So the main thread will only see mouse up, not mouse down.
I mean,
I think
Docker
to me
is
it's
a-
conceptually the same as an iframe, right? If I mouse down in an iframe, the parent document doesn't get to know about that. And if I drag across the iframe boundary, there's some funny things there that we got to fix up. But for the most part, when I drag across, the iframe gets a mouse leave saying that you've left
Yeah.
the frame, and the parent frame gets a mouse enter. To me,
And
canvas.
a lot of pages feel buggy when you go through that, so.
Yeah, because they
Yeah,
forgot
that's
to have the
the
mouse leave listener, right? I mean, you can always drag outside the window too, right?
I think like one thing a lot of sites like will add top level event listeners for like monitoring and things like
Yep.
that.
And
So
they're
that
already
might be-
blind to all the clicks you do on embedded YouTube
Yeah.
videos and stuff.
Yeah, but what about like hover state for CSS and all that stuff that we have to figure out? Like we still got to send it to main.
But why is an Offscreen campus not just conceptually the same as an iframe?
I guess what use cases are you looking at by doing that?
Well, the low latency status.
Well, no, well, you're not. But if you do, you can still dispatch them twice, and then just the worker is just a passive string. You can't
Okay.
cancel it and anything like that, and you still can do your low latency stuff, and then main just behaves as if it's.
is there any interesting cancellation behavior for any of these events on a canvas? Like obviously if you cancel on a link, that has some impact, but if you cancel a click event on a canvas,
Yeah, maybe,
does anything happen?
I mean, canceling touch end prevents the click event from being generated,
I see.
so maybe you might care about that.
That's interesting.
Do you want to do anything with long press somehow?
Right. Yeah, if you want to suppress the long press context menu.
Yeah, like you want your own context menu.
Yeah.
So
That's
like, but the state of the world on the main thread, you should be able to prevent defaulted on the main thread while still drawing on the events only. But you could write an app that did kind of knew both, right?
We probably wouldn't even send the if you were sending it to both, you wouldn't send the gestures to the canvas at all, right? So you wouldn't see the click event on the gesture.
The canvas would just get the raw mouse move.
It would just be.
Yeah,
you just say pointer events.
Yeah. Okay. So what's the events are we talking about here? Are we going to do all the input events or only pointer events? Or like
Pointer events. Pointer events.
I don't know.
Pointer events.
Yep. Yeah. All right. I mean, that leaves Apple behind in our like quest for another implementer, but you guys are the experts.
Experts in living Apple.
Well, conceptually, if it's passive events, you could possibly write a polyfill that, like, if Apple came along and said, okay, we're going to do touch events, you could write a polyfill for Chrome that took pointer events to touch events.
I think like that would be something down the line if they're interested in Offscreen canvas. Make it look. We really want just start touch whatever.
Every time we add something to pointer events, right? We just added rotation. Like every time we add something to pointer events, there was one recently where Dean added some stuff to touch events that we had already in pointer events, and we said like, we're not actively driving touch events forward, but when you do, if you like work with us, so we're kind of using it as a bit of a carrot. I actually got him to participate in the work group a little bit, and he didn't get fired for it. Perhaps. He didn't actually participate. He just commented.
Oh. Okay. Well,
Yeah, I think we're over time.
Well, awesome stuff.
But it's the last, there's nothing after this.
So there's like.
So if you go with like C, that means you would add event listeners directly on Offscreen canvas on the worker side for events.
Yeah.
It wouldn't be like self or global necessarily.
Right.
Yeah.
Right.
Then
Offscreen
that
canvas
was
is
for
already in events, right?
But the problem is that like if the question comes up for the event general, right?
Yeah.
Then it look messy, right? Where one special solution for this one, then the solution goes some other way. Right? The long term is bad.
You can't transfer an Offscreen canvas to a shared worker.
We still got